Over the next few videos, we are going to create an OBJ importer. OBJ being a file format that is supported by, well, several different 3D applications out there.
And basically it stores 3D data.
That's right. And so what we're going to do is introduce you guys to how you can write an application, well, basically how to write a class that's going to read in all of this data and assemble the model, if you will. And then we're going to create a very simple model viewer that will allow you to visualize that model in your own graphical application.
That's right. And once you know how to do this, it's not that hard to pick up the specifications of another 3D format and implement that one, because the same basic concepts apply. You need to load in your normal information, your vertex information, UVs, etc., etc.
Precisely. Not only that, but taking things one step further, if you wanted to, the moment you've got the data read in, you now have it yourself internally in your application, meaning that you can then save it out in a different format. You can work it with it in different ways, ways that could optimize the speed of it. I mean, there's a lot of different things you can do.
That's right.
So that you can utilize it in games, or if you wanted to create your own 3D type application, whatever.
Right.
So the idea here is just to introduce you to the file, to its format, and to how to get that data in and show it. So let's go ahead and advance to the next screen. Just a quick overview of what we're going to talk about. So first, of course, the overview video itself, which is
this.
What we're doing right now. Next thing what we're going to do in just a minute is talk about the OBJ file format. That's pretty important. We want to show you exactly what gets saved out when you're in another application and you tell that application to export a model out as an OBJ.
Right.
From there, we are going to create the header file.
Right,
our Model.h.
Yep.
That's right. And forewarning, it's going to be a lot of code.
This whole process is going to be quite code-intensive.
Very involved, yeah. So
luckily, though, it's not that complicated.
It's not that complicated. Well, some parts
are a little bit.
Some people may have some issues with because of what's going on. There's a lot of associations, and it's kind of like a lot of connecting up.
Yeah.
And as long as they can wrap their head around that, it should not be that bad.
We have plenty of explaining along the way.
Yes, we do. But we're going to create the header file first. From there, we are going to create the CPP file, but that's going to be divided into two videos. First, we're going to handle the OBJ loader portion of the CPP file. And then after that's complete, we're then going to move on to the MTL, or the material loader part.
Right.
And again, that's all in the model.cpp file.
Yep.
Now, up to this point, we have no way of compiling to test what we have.
Right. Basically, there's too many dependencies on everything else to have a really accurate compilation, really.
That's right. So because of that, we can't really hunt for any typo-type problems, or if we skip something, because there's so much code that we're doing here. That's just common.
Yep.
I mean, and we're just human. So we're going to have a check for errors video where we're going to do just that.
It'll be a short video, though.
We're going to more or less just debug any issues. Listen to Joel's confidence. That's right. And then from there, what we're going to do is create the OBJ viewer.
Right, which basically ties in our model class into a demo that basically allows us to utilize that class to actually see some models inside of our viewport.
And for doing the viewer, just to save time on typing, what we're going to do is utilize kind of a base application. It's a SDL demo that was created in the OpenGL VTM1.
Right.
And we're going to use a stripped-out version, a cleaned-up version. It's more or less just a viewport with some text that's refreshing the frame rate, and I think 3 lights.
Yeah.
And we're going to go from there and then add in the code, which is going to result in about 10 lines of code or something. It's very
very simple.
And if you're watching this video and creating this importer for some other project, you know, at that point it's just a matter of you seeing exactly what we're plugging in and then plug in the same types of things in your own application.
That's right.
Okay, so the first thing I'd like to do is let's just bring up the cube that we exported out as an OBJ.
In Maya?
So, no, not in Maya. Let's go ahead and jump over here. So, basically, we went into Maya, and we created a cube, a polygon cube.
Right.
And then we told it to export it out as an OBJ.
Yep.
Now, if you take the OBJ that got exported out and open it up into a text editor, this is what you're going to see.
Yep.
If you inspect the folder closely, you're going to see that 2 files were actually exported.
Right, and this
is 2 files
Maya.
were created.
Yep.
The cube.obj file and the cube.mtl file.
Which is a small little file here.
That's right. The OBJ file handles all of your vertices, your UV coordinates, your
And if you don't
normals.
mind, let me just block these sections out if you don't mind.
Okay, I was going to actually, in a second, revisit it and talk about each of the areas.
Yeah, go ahead.
So it basically holds all of this geometry type information. And then the MTL file holds
let me just
our
switch over here.
material information.
Right.
And so that's the two files that we have. And, of course, both of these files are extremely important when we go to import this into our own application.
Definitely.
That's why we're kind of dividing it up. Again, we're dealing with anywhere up to 700-800 lines of code for the importer, and we just really need to make sure we stay as focused and organized as possible because it's a big project.
Yes, it is.
Now, let's go ahead and jump back over to the OBJ. Joel, if you want,
sure.
Take us on a stroll through the format.
At the very top, we have a # followed by a comment. So these lines are simply ignored. And then we get to our MTL library, which basically says which material library file are we associated with. And q.mtl is what was exported along with it, so we know the association. And group essentially specifies the group that we're dealing with, the default group. And at this point, it basically starts defining the vertices, the texture coordinates, and the UVWs. Texture coordinates and normals, excuse me.
That's right. And there's a very specific pattern to how these lines are being created.
Right. Basically, we have our vertices here, our texture coordinates here, and then all of our normal information right here. And then basically what it's doing is simply basically a command followed by some sort of parameters is going on here. So you'll notice material lib is basically a command followed by a file name, G group followed by a name, vertex followed by X, Y, and Z coordinates, etc., etc. And you can see the same pattern through every single command that we have. And then once we have all that information, we come down to here where it creates a group or an object called cube. And then we say use material initial shading group, and basically this is the material inside of our cube.mtl file that's being created. And then we specify a face, because notice we have 1, 2, 3, 4, 5, 6 faces, which is right for our cube.
That's correct.
And it's basically specified into 3 different numbers, if you will. So we have our vertex.
And all of that, if you kind of want to highlight all 3.
Yeah, okay.
That's like one vertex.
That is one vertex.
Exactly.
Along that stores.
There's more information in there, but if you guys remember through OpenGL VTM number 1, when you're dealing with a vertex, you're also dealing with, if you're going to use textures, a coordinate, and you're dealing with normal information.
Yep. Basically, each of these vertices has a number associated with it. So this one's vertex number 1, number 2, number 3, 4, 5, 6, 7, and 8.
Right.
And when we get down into here, each of these is an index into that array. So this one's axis vertex 1.
So vertex 1 has the vector you saw up above, and then
we use a specific
now
texture
we have a coordinate.
And then, so this is vertex followed by texture coordinate followed by normal.
That's right.
And then we simply look in each of our lists to find which one we're talking about.
Right.
And same goes for every single vertex here.
And so we're making a quad there, basically.
Yep, we're making a simple quad because we have 1 vertex, 2 vertex, 3 vertex, 3 vertex, and finally our 4th vertex.
That's right.
So that specifies 1 face. And if we switch over to MTL file, so that's basically all there is to an OBJ file. Let me specify one other thing, that there's a variation of this, if you will, that basically allows us to specify 2 slashes. That basically says we have a vertex and we have a normal, but we don't have a UVW coordinate.
Right.
So this is just another way that you can do, and our OBJ loader needs to be able to support that, because it is possible that whatever you export does not have UV coordinates.
Right.
So let me just go ahead and delete that out. If we come over to our MTL file, you notice the first line basically just, again, command followed by parameters. So we have our new material command, and then it specifies the name of our new material. And then everything following that until another material is created are basically the parameters to this material that you've created. So our illumination is going to be 4. Our diffuse color, our constant diffuse color is going to be 0.5, 0.5, 0.5, which is a medium gray.
Right.
And our ambient constant is going to be black. Our transparency is going to be full transparency. And we have our normal.
Okay.
Shininess? Shininess, thank you. I was like normal. I saw the N and it just said normal.
I gotcha.
Yeah.
Now, if we had textures.
If we had textured, we'd have something like diffuse map followed by a file name.
That's right. And there's several different map types. We've got the specular color map. We've got our diffuse map, bump map, etc. And we're going to set up the viewer in the very end just to deal with diffuse map.
Right, but basically, if you want to extend it, our model class is actually loading all of that information in.
The importer is bringing all of it in.
Right, but we're basically not utilizing it in the draw code.
That's right. Okay, so with that, let's jump over to Maya real quick and show them that we have a couple of models that we plan on bringing in.
Yeah, so to test, if you will. So let me just bring this over here. Actually, if I go over into this folder right here. Basically, we have our models directory, so we have a mech that we're going to show off, as well as a ship. So let me go ahead and load these in. Let me just copy this path right here and paste this in. And so let me load our mech. Just give it a second. So this is the mech that we're going to actually load into our final thing.
Used in the Maya Fundamentals class. It's what students create in that class.
Right. And let's go ahead and export it out to this folder right here, just to show you how exactly that would work. So simply File, Export All, and then go to this folder here. Let me create another folder called Mech, just to kind of differentiate it from the ship. And let me just export this out as Mech. And simply click Export. Give it a second. If I go back into my folder here, you notice that we have our mech directory, and notice it copied over automatically all the TGAs, all the textures that are associated with this particular OBJ file, all of these, and it also exported out an OBJ file and an MTL file. You'll notice the MTL file, if we just kind of drag and drop this into context here, is pretty small. We do have quite a few materials inside of here. And our OBJ file is huge.
Very big.
Like tons and tons, and 3 megs of data here. So this is one of the files that we're going to be loading. I'll go ahead and export out the other one as well.
Sure.
Come back over into Maya, and let me just open up, go up one folder, go to my ship, open up the ship. No, I don't want to save.
Another project they create in the class.
Yep. So here's our little spaceship. And I'm going to export this out as well, so export all. And go up a directory and just create a ship folder. And just call this ship. So it's very simple. Inside of pretty much any 3D application, if it doesn't contain an OBJ exporter, someone probably need one. So no matter what application you're using, it's very simple to export it out.
That's right.
And if we come back over into our folder here and just go up one into our ship, you'll notice it exported the 2 textures that are associated with our ship model and our OBJ file and MTL file.
So the bottom line is for the importer, what we need to do is we're going to start dealing with files.
Yep.
We're going to need to open up our OBJ file. We're going to need to do lots and lots of parsing.
Yes.
Because we're going to have to read in a line and then break that line up to figure out what's associated with what. Like here we are dealing with 1, so now we need to associate this space, this vertex with these coordinates, with this normal, with this ST or UV coordinate.
Right. And so on and so forth.
And so on and so on and so on.
But the parsing is kind of sort of simplified because we're using a iStringStream class that allows us to do a lot of simplified texture, string handling, if you will.
Now, I don't know if you can get to it. Are you able to actually get to the viewer in the end? If you go up one?
Let me check.
You might. And if we have to...
Let me just copy this over.
Okay. Now, this is kind of what we're going for. Give it just a second to load through the data here. It's loading. It's mech's kind of big.
Yes.
So this is what we're going for in the very end.
So this is our mech, so just now, like we saw over in Maya.
Notice it's no longer in Maya. It's in our application.
Oh, yeah.
Which is cool. So we got a little frames per second in the right-hand corner, and we've got a list box, a custom list box that we've created.
And
we can simply switch between the different models.
So our spaceship and our mech.
Yeah, it's just
pretty
that
cool.
Simple. Okay, so now you know what we're going for. You know what the OBJ and MTL file formats look like. Now it's just a matter of lots and lots of coding. So bear with us. This is going to be an interesting ride. So with that, that's going to wrap up the introduction. Let's get busy.